I am Jay Kumar and I'll be your instructor for the Design Patterns course. Little bit about myself. I'm an enterprise architect with about 11 years of experience. These are our objectives. We try understanding what a design pattern would be. We will perhaps talk about UML diagrams. We will talk about importance of design patterns. We'll know about different categories of the design patterns, and we'll try and implement a data access object and a factory pattern today. The design, the software design is a phase-wise approach. Basically, it's a three-step process. Starting from the bottom, we decompose system into modules. We decide how those modules are related. In fact, the module decomposition and their relationship happens generally at a software architecture level. I can speak about it because that's one of the parts that I keep doing, but it is more important to decompose a system into meaningful modules, tell what is their relationship, and then describe those modules individually. And you see these animated diagrams, or not so animated, the cartoon diagrams, which are putting pieces of puzzle together. Now, I'll tell you that is an interesting diagram if you really look at it closely. Each of that block, right, the piece of puzzle, is really a module. How do they interact with each other is the interface, right? And what color they are, or kind of what is the size of them, or what is the weight of them, volume of them, is really their internal state. We don't really care as long as their interface is intact and they are coming together. So, reiterating, decomposing a module will say what is a meaningful module, what are the interfaces they expose, right? By interfaces, I do not necessarily mean Java interface. Okay, so I want to be very clear there. An interface could be a web service interface or an EJB interface. It may just be a Java API interface. It may just be a database interaction, right? Any kind of interface that defines the contract between two modules. That contract is going to tell what is the relationship between module. On top of that, there will also be places where you'll think, oh, it's not just about the contract, right, the interface, but it's also when does it get triggered and how the systems, these modules, discover each other. For example, in case of an EJB, you will do probably a JNDI lookup. In case of web service, you will perhaps do a UDDI lookup and something of that sort. Most essentially, the last piece is describe that module's functionality individually, right? That's when you say, okay, I did say that there will be a sensible module, but what exactly that module is going to do? That happens in the third step. It's quite an interesting name, solid principle. They're really solid. But essentially it is an acronym that stands for Single Responsibility Principle, Open and Close Principle, Liskov's Substitution Principle, Interface Segregation Principle, and Dependency Inversion Principle. We'll look at each of them individually and see what they are really. You will find a lot of text around it, explaining it in different ways, but we'll try to make it simple and say, what they are. Perhaps we will describe it in such a way that we remember. And we'll also see what happens if you don't meet or don't follow that principle. What is the consequence? A single responsibility principle says that there should be never more than one reason for a class to change. Means that every class in your code should have only one job to do. And everything then in that class should be related to that single purpose. That does not mean that your class should contain only one method and property. That's very important. Generally, when I describe single responsibility principle, what ends up happening is, we misunderstand by saying, oh, that means I should only have, one method and everybody should only call that one method. And that also means that then your one method becomes something called a God method, right? Which we'll talk about in the anti-patterns. Single responsive when I think of single responsibility principle, right? I'll tell you about the thing that comes to my mind. When I think single responsibility principle, I always think of a needle, and actually a tip of a needle, right? The only purpose that that tip of the needle has is to perhaps punch a hole, you know. Apart from that, you could use it for some other things, but that is a focal point. It's just one focus in the life of that particular object. The text would say that there should be no more than one reason to change a class. That's the criteria that you apply when you say, what is this class going to do? Right? Now, why single responsibility principle? Let's talk with an example in here. Let's say you create a class called calculate and save. I'll tell you the first violation there and there itself. No class should ever be a verb. Okay, but we are taking it here to just show an example, and therefore you will also see that the classes in the bottom are also just an example. You will perhaps have a calculator as a class, right? So let's say you have a class called calculate and save, and what it does is it calculates and writes some file. So in here, this class is responsible for calculating something, writing to a PDF file, writing to an XML file, and writing to a plain text file based on maybe what are the configuration parameters given to this object. You know, maybe the object was told to just write to a PDF file, in which case it will not write to XML file, and so on and so forth. But imagine what happens. Imagine you want to change the way the calculations were to work. Maybe you wanted to apply a discounting model. You need to change this class. That's one reason, right? The other reason is you want to change the layout or a structure of a PDF or an XML or a plain text file. There are three more reasons then to change this class. What is a better way to do it? A better way to do it is you create one class for each of these. One responsible for calculating, another for saving it to PDF, another for saving it to XML. That way, each of this class will have only one reason to change. Now, take it with a pinch of salt. In a practical world, you will go even more evolved than that. You will perhaps say a file persister, and that file persister you will apply certain design patterns to say whether it should be PDF or XML or plain text. But the point to understand here is each of these class only have one reason to change. Also note that it shows one method there, but that's not mandatory. What is mandatory is that each of these classes do only one thing in their life. Now they may be stepwise, they may be doing it stepwise, but purpose is only one. For example, a calculate object may have a discounting model wherein it may have another method called set discount, right? Or a save PDF may have another method called set file name or set file path. So can save XML. It is not necessary to have say single method. It is necessary to have only one goal in that object's life. With that, I will move on. Next one is an open and close principle. Interesting one, right? You put in two oppositely meaning words together and say call it a principle. So we have to understand what it is open for and what it is closed for. An object should always be open for extension. That means you should be able to reuse that object by some means. In most often cases, this will be a by means of extending the functionality. That means by means of subclassing the object. but it should be closed for modification, which means once you have developed a class, you should not go and change that class unless there are defects or bugs. Very important. Let me bring in another aspect. I don't know how many of us do something called a test driven development, or if not that pure, I wonder how many of us do the JUnit or some sort of unit testing on the classes. Because if you do, you will in one way or the other meeting some of these principles. Why should a particular object be closed for modification? Because perhaps you've already written the JUnit classes, which will test this class, right? And if you change it, you have to go and change the JUnit class. Well, that's not a bigger deal, right? What is a bigger deal? Bigger deal is really JUnit classes that you are writing were mimicking how your client is going to use your class. Well, you can change the JUnit class, but do you want to change also the client code of your class? Perhaps no, right? And that's where I'll bring in something called a ripple effect. A ripple effect means that you changed one thing, and because you changed one thing, there were more than one other things that you needed to change. And it's really a ripple, right? Consider that there is a calm water and you put a stone, drop a stone, and it will create those waveforms. That's a ripple. That stone is the change that you introduce into a system. The moment you introduce it, how much is the ripple that it's going to cause? That's the question. If your class is not closed for modification, that means you can come at will later on and make changes to the class. That would mean that you have to also care for any ripple effect that it may cause. You may change the JUnit classes because they are within your project, but then you'll have to perhaps tell to other guys who are owning the client code to change it. And if you are working in a distributed systems like I do, you have quite a mess at hand, because you have to go upgrade those 20,000 different software agents that are sitting there, and that's not an easy job to do. Now, having said that, let's talk about close for modification one more time, because I also don't want to give you a feel that once a class definition is available, you should never ever be changing it. What you should never ever be able to change is the syntax, the methods, signatures in the technical terms that the client is dependent on, and general semantics of the behavior of the system. So understanding that you should never be changing the method signature is easy because the compiler will crib. But it is more important to understand the semantics and the meaning of that method. You may start changing the code internally, and you may start throwing, let's say, illegal argument exception, which is an unchecked exception, and you have got your client off guard. All of a sudden there is this runtime exception coming in, which client has never considered, because you can throw runtime exception without changing the method signature. That's the behavior that we should not be doing. That's a modification that we should not be doing. But let's say you do want to validate those parameters, and you do want to say that it is an illegal argument exception, for example. What are your options? Your option is to extend that class. You create a subclass, override that method, and in there you say that when you use this method, I'm going to cause you a illegal argument exception. That way, it is up to the client who was instantiating your classes to decide which one of the behavior that they want to choose. Now, the pre-existing classes will be creating the instances of your older class, because they wouldn't know about your newer class, right? So they are safe there. They will never get that illegal argument exception. But your newer class will now be available to the newer clients that may get developed, or newer versions of the client that may get developed, and therefore they can be sure that okay, if my input parameter are going to get validated and I may get illegal argument exception. There is a question here by Divyang, and the question is quite interesting. It says, what is modification in open and close principle? What I would like to do is I would like to complete the open close principle, and then I like to answer the question. Meanwhile, if there are other questions, do send those in. Here is an example of why we think open and close principle is important. Consider a class called draw editor. Look at it. Now we are doing a good thing. We are saying that the class is always a noun. It's a draw editor. It draws a rectangle, draws a circle, draws a square. This in some way, right, is at some level is complying to a single responsibility principle, and I'll come to it in a minute. Why and why not also. Point that I would like to emphasize here is all these principles are kind of overlapping. You comply to one and you will perhaps be complying to other one automatically, but the reverse is more apparent. You break one principle and you are perhaps breaking the other principles too. So we have a draw editor here, and the draw editor is going to be able to draw rectangle, circle, and square. Now let's say you wanted to add another behavior to it called draw eclipse, and it will draw this eclipse here, and you have to then go and change this draw editor to introduce this particular drawing method. Now if you remember the single responsibility principle, we said that there should only be one reason to change the draw editor. Well, one can argue a case that the purpose of draw editor in its life is to draw something, and therefore introducing a draw editor draw eclipse method is just fine. Well, let's stick to that just for a minute. But it also means that you have now exposed and added a new method to this class, and anybody who was using the draw rectangle, draw circle, draw square will still be able to use it, but they will not be able to use draw eclipse unless you give a newer copy of this class, and they may find, right? So what will happen is, let's say your client wanted to draw an eclipse and they had an older copy of draw editor. They wouldn't be able to draw the eclipse, and still the guys who have the newer copy of draw editor will be able to draw eclipse. That means you have the same class, two versions of it, they're behaving differently. This is just an example telling why we should not be allowing modification, and here we are showing what is the better way of doing it. Now in a single responsibility principle applying to draw editor, we said, oh, the only purpose of life in the draw editor is to draw something, and we are now saying, oh, draw something is too vague. Let's say draw a shape, and shape being the level of abstraction here. Now the specialization of that shape could be rectangle, circle, or ellipse, or square, and the responsibility of drawing themselves is given to those individual classes. In here, let's say you were to introduce ellipse later, you don't even have to change the draw editor, you just have to extend the shape as a class. So therefore you don't have to modify the draw editor. It is the client who is interested in eclipse can now create an instance of eclipse and say shape dot pass that eclipse as an instance to draw shape, and draw editor will happily draw it somewhere. What are we highlighting here? We are highlighting that you don't have to change the draw editor just because you wanted to add new function. You just have to extend the functionality by subclassing the shape object and leave it to our clients to decide which shape they want to draw, which we were doing even the last time. But what is happening now is if there are clients who want to draw Eclipse, we let them draw Eclipse even with the older copy of the draw editor. In fact, since we are not required to change any draw editor, as long as the client has some way of instantiating the Eclipse object, we are good. Consider the ripple effect here. Is there any ripple effect for the older clients? No. Is there any ripple effect with the newer client? Perhaps no. The only change that we have ever introduced is being able to introduce an Eclipse object, and if the client wants to use it, that's the change that they'll have to do by some way of instantiating this ripple object, Eclipse object. Let's see. Before I move on to Liskov's substitution principle, let me go to the question. There are two interesting questions. The first question I'll read out from Divyang is what is modification in open and close principle? He was confused, but that was a while ago. So I'm going to unmute Divyang and see if he still has a question. Divyang.
So in the draw editor with a class, okay, we had added an Eclipse a method to draw an Eclipse. Okay, so that by doing it we are extending the functionality of the draw editor class, and at the same time we are modifying also. So still, actually, I'm confused.
Sure. So let's talk about that. There is a basic assumption that we made here, and I should have called it out, is that we are able to make the changes to the draw editor class if we have the source code with us, right? What happens if you did not have the source code for draw editor? How do you support drawing Eclipse, right? That's the way. By mean of extension, what we generally do is we subclass the draw editor, and then we will have this draw Eclipse method, right? So there we are definitely extending the functionality, as you said, but what we are doing is we are also modifying the class. In the sense, what is a class? A class is some representation of a class of object, right? A blueprint. A draw editor is a blueprint. We are changing that blueprint, may it be by the subclass itself. So anybody who was using the draw editor had 3 methods, right? But they will never have the 4th method even if you had subclassed it. Why? Because you've added a new method which was not there in the superclass or parent class, and anybody who was only referring to the instance type draw editor, right, the type reference variable of type draw editor, will never have the draw Eclipse method. So we are not really extending the functionality in the sense that those guys who were having reference to draw editor are not getting this extension to the functionality. All they are getting is only these three methods, ability to draw three kind of shapes. And at the end, same time, we started adding more things to this draw editor, which will be okay depending on the context. But for the context of this, since your intention was to extend the functionality, what you ended up doing is modifying the blueprint, right? Now that blueprint is not really a specialization if you really think of it, right? Why? Because that specialization cannot be applied to the draw editor. Let me take that example of inheritance then. My grandfather was able to speak, right? So I can speak, but I can speak, let's say, 3 different languages. So I have specialized it. Have I added a new behavior? No, not really. I can speak, so can my grandfather, just that that speaking is specialized. Never in my inheritance hierarchy I'll ever say, speak Hindi or speak English. I'll only say speak. Perhaps I'll pass a different type of parameter, and if you perhaps send speak English to my grandfather's object, it'll say, oh, I don't support it. But if you say speak English to a Jay Kumar object, it'll say, thank you, hello, or hello, how are you? So that way I did added a new functionality by way of extending it without changing or modifying my outward behavior. And that's what the modifications are all about. You should never modify the outward behavior that is exposed, but you should still be able to extend on that outward behavior to introduce newer ways of doing things. Okay. Did that help?
Yes.
Okay, thank you very much. Do you have any subsequent question? Okay, so there is a request for a break for 2 minutes. Anupama, if I may take only 1 minute, maybe. I just want to get closure on open and close principle, take perhaps a break and then come. Oh, great. So Anupama is back too. Perhaps I looked at it a little late. Okay, let's continue. Chirag, you have a question. Won't extending new class be creating a duplication? I'll unmute you and see, and I'll try and answer the question and then unmute you. No, extending a new class does not necessarily mean code duplication. What we end up doing is, let's say in case of our example where we wanted to validate the input parameter, we will be calling, doing the input parameter validation, and then we will be calling super dot whatever that super method was. So we don't duplicate the code. I'm going to unmute you and see if I answered your question or if you have a subsequent question.
Well, I understand that you can just call super, but what I was thinking was like, why do you? So basically, when I was thinking about an example, when you talked about this PDF example, or like save a PDF and you throw an IO exception or something like that. So, and you said like when the client actually extend that client flow code doesn't need to be changed, but for that, if you're writing a chain and everything, you have to write a lot of code even to test that particular class. So for example, if in here, when you say that it's a save PDF, or like now you have a save PDF method, right, and that throws an IO exception. Now when you actually go ahead and extend the class and save PDF XYZ, and that particular also has save PDF itself, which extends the save PDF, and now that is throwing an IO exception. Now the entire code has, for just one change, I have to change entire class for an extension, and I have to write the JUnit against that too.
Right, good question. Let me bring in one more aspect to it. What the example that we are taking are really very, very simplistic. In a real world, right? In a real world, if you are to save PDF or any XML, right, what you will do is you will actually break it down to further level. Right, you will say, oh, saving PDF is really a monolithic operation. I don't want to do it today. What do I want to do? I want to take the input parameters, validate them. Perhaps you will create another public method, or perhaps not even public, a protected method, right? You will say, let me do the input validation. Then you will say, let me format or massage my incoming data so that it is suitable for me.
There can be a number of methods in the same class.
Right?
So doing something with data, to opening a new file, creating a new file, getting new, getting the name of something. There can be millions of methods in this, but just for that particular. So basically, we're just talking about the template you're describing, right? Not anything more.
One way.
Go ahead, it's fine.
Right. So I essentially am not describing a template method. Template method is yet another thing which we'll talk about. But this is really, because in template method you will end up, and for others, just hold on. We will talk about template method, okay? But just want to answer Chirag's question. In a template method, all the steps in the method are kind of public. When you are building your class, you will perhaps make them protected. Only subclass has the visibility to it. And that's an interesting one. How should we be describing our methods? Describing method is a skill, and one of the criteria is unit of work. And therefore, why should you be considering that unit of work? Because that unit of work might change in future. And if you want to change that unit of work, you should be able to subclass it and only override that method wherein you need that change. For example, massaging an input parameter into something more convenient is one unit stage, one unit of work. And
Yes.
when you subclass, let's say save PDF, and you just want to change that particular unit of work, you will only override that particular method, and rest of all you will reuse. That is how we end up reusing. Now there could be certain cases where you can't really avoid duplicating the code, but that happens when while designing the base class, the consideration was not given to these unit of work. Every work can be broken down into a smaller pieces, and what is the criteria that I'm suggesting that smaller pieces is a single unit of work, something that can happen together. For example, opening a file is one unit of work. Whether you open a local file or a remote file, or whether you decide to create a file if it is not present, is one logical group of work. You might want to create a method for that. Tomorrow if something changes, you just override it and remaining things remain the same. So in reality, what ends up happening is you can only avoid duplication if your base class was designed with that kind of changeability in mind. And therefore, if you were the designer for a greenfield project for the first time, right, you may want to err on creating many protected methods than a single monolithic public method. This public method will use this protected methods to achieve a job, and that's how a universal principle in software development always be divide and conquer. You keep dividing up to a point where you think division any further is no longer going to be beneficial. Liskov's substitution principle, what it essentially says is we should be able to replace a particular class with any of its derived class, wherein derived class may have a changed a behavior, thereby specializing it, but the derived class should not change a behavior which is not expected out of a base class. For example, if my base class did say calculate my salary, well, any subclass on that should always calculate my salary and not perhaps my maybe biological age or my emotional age or any of that sort, right? Now, if the subclass is checks whether my boss is happy with me or not and decides on that, it may change the way my salary gets paid. Maybe my boss is very happy with me and I get 20% bonus. Unlikely in these days, but I would like to think positive. But essentially, it is going to compute or calculate the salary and nothing else. Also, since my salary can never be negative, that is, I don't owe money back to my company, no subclass should ever compute a salary, a negative salary. Why is substitution principle really required, right? That's one thing. We'll look at the example, but let's look at why the substitution principle is vital for a good software design. Liskov principle says that we will, when a particular base class is replaced by its derived class or a subclass, the behaviors should not be surprising. Essentially it means that I can replace a class with any of its derived class. To take an example, if somebody is interacting with my grandfather, my grandfather may very well be replaced by me, and I'll still be able to behave as a human being, right? Because all of us are essentially human. Let's take an example of save PDF. If save PDF was replaced by save PDF2 class that we described, then save PDF2 class should still be able to save the file to PDF only, and it should not save it into XML. That's the other critical part, right? It should not surprise the client. That's what the Liskov substitution principle will be doing. Now, remember that these principles apply across object-oriented world. In Java makes sure by way of syntax checking that you don't surprise the client classes by way of changing the syntaxes. But again, Java may not be able to verify whether you have changed the internal behavior itself. The meaning is the most important, right? Say for example, a calculator, if it was supposed to calculate my salary, a subclass of that calculator should not start computing maybe my height or weight or my age, right? What it may do is it may give me perhaps a bonus in my paycheck if my boss was happy and I was selected for that extra bonus, but it is still my salary, still my paycheck, right? That's what the substitution principle is going to talk about. What example we are going to take here is a rectangle and a square, and we will see why this is not really the best of the ideas. A rectangle has a length and a breadth, right? You will be able to do some set those values, and when you say get area, it is going to be a multiplication of length and breadth. But let's say you create a subclass called square of that rectangle, then both length and breadth are going to be one and the same, right? The logic will tell us that, square is nothing but perhaps a specialization of rectangle. What will be interesting to see is what happens to the client who is saying get me the rectangle, right? And then the client is going to say set the breadth and set the length, and the client is, since client is thinking rectangle, they are really going to say, okay, so my area may perhaps be maybe 26, 24. But let's say if your Liskov violation test.get rectangle was really giving out the square, the client will be surprised. The client will say, oh, this is really, why is my area coming 36 when I'm thinking rectangle? And therefore this cannot be, the square cannot be replacing rectangle by virtue of just subclassing it and setting those values, because you have changed the meaning of length and breadth. What really needs to happen is those two should be different classes. Perhaps if we want to make it more evolved example, both should be some sort of shapes, right? And shape will have dimensions, right? But let's talk about here. A rectangle will always have length and breadth, and the square will have a side. And client always knows that when I say rectangle, it is indeed going to be rectangle, and the area will always be correct. So this does not violate the Liskov substitution principle. In fact, it does not even do the substitution. But this does not end here. What really would happen here is that if you really want, this is just showing the violation of the principle, right? We should also consider what is the compliance of the principle. So what may end up happening is, if you still want to have some sort of relationship in the rectangle and square, you will create a subclass called a superclass called shape. Shape will have a way of saying set dimension, right? And in case of rectangle, you will say set dimension length and breadth. In case of square, you will set dimension side and side. And thus, when you say test.get me a shape, and let's say shape is that of rectangle, you will say shape.set dimension. And because you know now the dimensions, you set it. No matter whether it is rectangle or square, it will always give you the correct area. And you are not really worried about what kind of shape you are getting. You're just worried about, given the shape dimensions, what is the area. Now in here, that shape can be faithfully replaced by the rectangle as well as square. What is the most important part here? The most important part here is, because you are giving the shape as an object, client cannot make any assumptions. It is some sort of shape. I just need to give, let's say, 2 dimensions, and I will get an area. Right? The client does not know whether it is rectangle or square. The client cannot make an assumption that if it was rectangle, this should be the case, and if it was square, this should be the case. Right? And that will allow us to swap out that shape with any other kind of shape, right? Let's say today it is square and rectangle. There may be a square with a thickness, or a trapezoid, or a parallelogram, right? Doesn't matter. What matters is, given the dimensions, can I measure a area? With that, moving on. Here it does say questions, but we took a break, so I want to finish next 2 topics and then come back to questions, and I don't see any pending questions here, so I'll move on. Interface segregation principle. Now interface segregation, when you think about interface segregation, think about abstraction always. Since we put a lot of time on abstraction, I can tell you, and this will be an easier one to digest for you. What it really means is that a particular class should only be, the particular class should only be showing certain behaviors from the point of view of a viewer, right? And that the point of view, the viewer or a client, should only be using that class only for the purposes that client is interested in, and nothing else. Interface segregation principle practically would mean that you create as many interfaces, and this could be then Java interfaces, to an existing class, as many as there are viewers or observers to this class. And you should never shy away from creating interfaces in Java. And your client should always use interfaces to interact with the class, and never the actual class name or class type. That way, now if you do a right interface segregation, right, and when we look at example, it will become more apparent. You are also meeting your Liskov substitution principle, because now your point of view is only one. It is easy to replace the implementing class by another implementing class from which is kind of implementing the same interface. And let's talk about example. Okay, but before I go there, I should also tell you that because now your point of view is only related to your what you are really interested in, you're not getting into complexity of any other thing that underlying class could be doing, which is a good thing. That allows you to maintain your code by swapping out the older implementation with the newer ones. Here is an example. Example is animal, right? And this is actually a violating example. An animal can fly, run, make sound, maybe crawl, and all those things. But if you start implementing dog as animal and crane as animal, well, dog can't fly, and perhaps crane cannot crawl. But since your client will be using animal as an interface, the client will be able to execute a fly method on all, and if it executes fly method on dog, nothing will happen. Also remember that this is somehow not really the compliant example of also a single responsibility principle. You're making animal do all sort of stuff. although it is not necessary for that animal to fly. It is also not correct level of abstraction, because when you are looking at animal, you are perhaps looking at only some sort of animal kingdom, which is probably a land base, perhaps, right? And is not definitely standing on two legs, right? Will have four limbs. Those limbs could be a different form, and will make some sort of sound. So if you start using something like this is a clear violation of interface segregation principle. You can also not replace it, because maybe a newer implementation of animal class, instead of saying do nothing for crawl, may start throwing unsupported operation, and you are in a soup then. What is the correct way of doing it? Here you go. You create interface fly, sound, runner, and crawl. And then you implement those interfaces to the correct set of animals. For example, a dog can run and make sound. A crane can probably fly, run, and make sound. Thus, anybody who uses a runner interface knows that any particular instance that is coming its way will be able to run, and there is no exception to it. And by way of exception, I don't mean Java exception. There is no exception to that rule. Any instance of a sound will be able to make a sound, and there is no exception to it. If you look at this will tell you that if you do the right interface segregation, you will also be able to comply to some extent to Liskov substitution principle. What is that remaining part of Liskov substitution principle? That a dog who is implementing runner should not start flying, should not do something which is not equivalent of running. The next principle that we are going to look at is dependency inversion principle. It essentially means that, again, it is related to abstraction. It essentially means that the higher level modules, right? Every software will have certain levels of complexity, and we looked at that the design starts with the module. It means that you break the modules at the right level. The higher level modules should not depend on its operation on the lower level modules, but it should be based on some sort of abstraction. Secondly, it should always be abstraction. You should not know the internal nitty-gritties of those abstractions, and the internal nitty-gritties should be compliant to your abstraction. For example, if I was saying save file, the internal implementation should save file. But if I am calling a save file method, I should be sure that I don't know how the file is going to save. Will it be storing into an NTFS or a flat file or a remote file server, or maybe sometimes in some sort of database? I don't care. As long as it's going to save file, I'm happy. So that's last two. Abstraction should not depend on detail, and detail should depend on abstraction. That is, detail should be compliant to what abstraction is saying that it is going to do. We will talk about what does it mean by saying high level module should not depend on the low level module. Consider a level of an organization with different level of employees. The low level employees will communicate with the team lead, and the team lead will pass on information to the higher level employee. Abstraction level is your team lead. Now imagine a chaos if your CEO starts talking to each individual employee. That would be unmanageable, right? Similarly, everybody on your organization needs to talk to CEO. They would always be not so friendly. You wouldn't know how to talk to a CEO, perhaps. But you can always leave it to the middle level managers, your team leads, to pass on information. They can also pass on information that makes sense to the higher level management, and vice versa. So that's the dependency inversion principle. In case of, let's say, a software world, imagine a copy program without a dependency injection principle. A copy program reads from keyboard, writes to text file, and writes to database. And you will see that the copy program is really taking care of interacting with keyboard, which is a lower level abstraction, right? Or writing to a text file or a database, very low level abstraction. What is the purpose of copy program? Copy program's purpose is take it from source and move it, or create a clone of it in the destination. Now in here, the copy program knows that the source is a keyboard and a destination could be a text file and or a database. That's why this is a clear violation of dependency inversion principle. Copy program is a higher level module, whereas reading from a keyboard is a very low level module. So how do we do a dependency inversion? We say copy program is going to implement a reader interface or use a reader interface, that's a source, and it's going to use a writer interface, that's a destination, and a lower level module may choose to implement that reader interface. Maybe it is reading from keyboard, tomorrow it may start reading from a scanner. A writer interface today can be writing to a text file, but tomorrow it can start writing to a printer or a database. That way, copy program does not need to change even if the low level module has changed. It remains intact, because what are the other principles coming in here? Single responsibility, right? Copy program's responsibility is copy from source to destination. If the internal mechanism changes, copy program need not change internal mechanism of reading and writing, right? What is the other principle? Liskov substitution principle. As long as copy program is going to rely on reader interface, whether the reader interface is reading from keyboard or scanner, doesn't matter. The Liskov substitution principle will say that keyboard should actually read and read some characters or some data. It should not start writing to a disk or something like that. So that's where the other principles will come in. Before we start into design pattern, I think I covered three important principles. We are 20 minutes into the last hour, and I have a question here by Shikha saying, till what time will we have this class? The scheduled time is 10 o'clock, up to 10 a.m. But since we lost 10 minutes, I am going to extend it by 10 minutes and see how that goes. We are taking time and making sure that we understand the solid principle as well as the object-oriented principles, so that these are the principles that will be applied during the design pattern discussion, and I want to build that solid base. So I'm going to unmute Shikha and see if she has a subsequent question. Shikha?
Yeah, I'm good. I just joined it today and I didn't know the DR card. I just to work that. So I just went from and I figured still
Okay. So I'm hearing, if I'm hearing right, I'm hearing that you got the answer, and I'm gonna.
Yeah, I just.
Okay, thank you. Are there any other questions? I'll give it a 30 seconds for you to type in, and then I'll move on if there are no questions. Okay, so let's move on. Now we are entering into the area of design patterns. Two things here. One is design, the other one is pattern. What is a pattern? Pattern is some repetition that you can deduce. What's important is for something to call pattern, it should be easily observable, right? You will see a specific type of houses built in a specific geographical region. You will see specific kind of trees growing in a different geographic region. You will see a specific type of maybe doorknobs being used to in a particular decorated house, house with the interior decorator designed by decorator. It's a pattern, right? And what is important is human brain thinks better with the pattern. It is chaotic for a human brain if it does not see a pattern. And why is that? Perhaps because the way we store memory in our brain is by relating elements together, and pattern allows you to relate those elements together. Well, that's a generic sense pattern. What is a design pattern? Design pattern is when you see things done repetitively, right? And why are those things done repetitively? Because they are perhaps solving a problem of a similar kind. And these patterns are really discovered. They're never invented. You don't go and invent a pattern, because by very nature pattern is repetitive. What happens is you kind of discover the pattern. Many people start doing things in a different manner, and that becomes a pattern. Generally patterns are well documented, right? And they will have their forces, when to apply it, what are the consequences, what are the related patterns, and all that thing. And that's what I term as very scientific information about pattern. One can always go and read it. How much does one make sense of it? I don't know. And that's where I'm here with you to make sure that we make sense of most of the design patterns that we are going to cover. Essentially, it is a tactics, right? A design pattern is a way of a proven solution to a problem. But when to select that tactics is a skill, and that's the skill that we would like to build in this course. Moving on. In order to digest the design pattern, we would like to see the way they are classified. There are four major categories. One is a creational, the other is structural, behavior, and concurrency design pattern, and we're going to talk about each of these classifications in the subsequent slides. Let's look at creational pattern. A creational pattern, as name may be giving quite a good signal, is it's related to creating the instances of a particular class. Now you might be wondering, why do I have to worry about it? There is a new operator, right? And the new operator can always give me the newer instances of object. Why do I have to worry about how do I create the instance? Well, in the simplistic form, you don't need to. But if you apply the design principles, consider that if your client is required to create a new object and then operate on it, in the first place, you have violated single responsibility principle, because you are assigning two responsibility to your client. One is responsibility of creating a new instance. The second is using that instance. And there will be two reasons to change. Why? Because anytime you want to use a subclass, right, you would want to go and change the client class. Anytime your subclass has changed extended the behavior, you would want to go and change that class, because now you were changing the behavior of the subclass. Not a good idea, right? In the simplistic cases, it works. We say, okay, that's fine, not a big deal, smaller classes. When your projects or problem statement becomes complex, these smaller things matter. Imagine you having to create new classes at 10 different places, and then you want to replace it with the subclass. You have to change 10 different places. That's a ripple effect, right? You change one thing and now you have to change at 10 different things. And therefore, in a moderately complex problem situation, we end up hiding the new operator, avoid using the new operator all over the place. And we say, let's create some design, put in some design pattern that will allow us creating these objects. That's one aspect. What is the second aspect? Second aspect is you might be creating a simple object by using a default constructor, but tomorrow you might want to create the object adding in new parameters to your constructor, or you want to create the object with a simpler default constructor but want to initialize it. so that it can start serving or behaving properly, set some state on it, right? In earlier case, if you were using the new operator at 10 different places, now there are two options with you. One is don't change the default constructor, override the constructor, but then those old classes will not be able to make use of this newer behavior that you may have, newer way of operating that you may have added by changing the, adding the state, maybe initialization that is required. Or you will end up changing those all 10 classes. Again, ripple effect, multiple reasons for a class to change. That's where creational patterns are important, and the pattern that we are going to look at is abstract factory, builder, factory pattern, which we will be looking at today, a prototype pattern, a singleton, and object pool. The next one we are going to look at is a structural pattern. Why is structural pattern required? Again, going back to our principles, since we want a single responsibility, a level of abstraction and interface, I can't really write a lot of logic in the same class, right? So what are my options? My options is to break down my my logic into a design that complies to my principle and perhaps into multiple classes. And then the structural pattern is going to talk about how these multiple classes relate together to achieve certain kind of business logic. And in here we will be talking about adapter, bridge, composition, decorator, facade, flyweight, front controller, module, and a proxy pattern. Remember that there is a specific characteristics of a structural pattern. A structural design pattern will always know about all its entity at the design time. Now those entities may be known by virtue of a base class or a interface, but it always knows it at compile time. It is not discovered, right? For example, a adapter will always know what interface it is adapting and what interface it is exposing. A facade will always know what is the method it is, what is the behavior it is exposing, and what is the granular level of methods or behaviors that it will be using. All that is known at design time. There comes our next category of design pattern called behavioral design pattern. Again, since we were talking about knowing the composition or knowing the other classes, in general, in behavior design pattern, those classes are not known. What is really known is or not attached at the compilation time. They are attached or given to it at the runtime. Again, they know the interfaces that are going to come. They may not know what exact instance is going to come, and they are generally chosen on the runtime based on the business logic. If I want to call out a difference in a proxy pattern, you will always be proxying to a particular service or a particular interface. You will not change that particular interface based on the business logic. But let's say in a command pattern, you will choose which command to run based on the business logic at the runtime. So we will be looking at chain of responsibility, command, iterator, mediator, observer, strategy, and what perhaps Chirag already knows, template method, and a visitor pattern. Now I'll also tell you, the more we go into the next level of design pattern, the complexity grows a bit. With that, moving on, we will be talking about concurrency design pattern, where we'll talk about active objects, monitor, half sync, half async, leader follower, thread specific, thread pool scheduler. All these patterns will talk about in a multi-threaded environment. How do I set up my project, right? My how do I do a modular decomposition such that I don't end up doing a deadlock or a live lock, as well as I make the most efficient use of my multi-threaded environment and still make it a maintainable code. We'll quickly go through UML. Remember that UML is not important or even mandatory for our understanding of the design pattern. It is just a diagrammatic presentation of an object-oriented world. It is common across all object-oriented world. It is not specific to a programming language, so you don't need to know how do I write a class or how do I write a if statement or a while loop or something like that. It is especially for the member of team who are higher enough in the chain of abstraction. If they want to just know about the class, we don't want them to go and read the class file or a Java file. We just show them a diagrammatic representation and they know what it is. Why UML? Again, as I said, perhaps your software architect or your manager wants to understand it, and you don't want them to go through the code to understand it. It's a visual representation, as they say, a picture speaks 1,000 words. So it will show those 1,000 words perhaps together. And it is a de facto standard, which means that if you have drawn a UML and give it to somebody else who understands UML, they will understand what you are trying to communicate. It's a means of communication between the development teams. Here we will be looking at the diagrams notation. You have a class on the left hand side, the code. On the right hand side, it shows a class. Highlighting here, the first box will always be the class name. It may put an annotation called class. The second box is always the attributes. The plus sign will mean public, the minus sign will mean private, hash will mean default. The bottom box rectangle will always mean the behavior, the methods. Again, plus, minus, and hash, same thing. The parenthesis string will say that it's an input parameter, and colon followed by whatever is a return parameter. That's how it will be represented. That's about how do you represent a class. Again, what I described: public, private, and protected for hash, class name, class members, operations, or methods. Moving on. Interface. An interface, again, three things, but as you can see, generally an interface will have an empty second box unless you want to write the constants. The attributes do not make sense. In case of interface, it will show methods. Remember that all methods in interface are always public. They cannot be private or protected methods. The arrow with a hollow head here shows the inheritance, that the person is being specialized into an employee class, and in Java you will say employee implements person. Okay, a package diagram shows all these classes together and how they are correlated. This arrow should be a hollow arrow. A bank account having owner, balance, deposit, withdrawal, and then checking account and saving account as a subclasses. Now subclasses may add on their own behavior, may specialize the behavior, or may add their own attributes or the members. Class association. Generally an association is shown by a single line without any arrowheads. There can be one-to-one or one-to-many association. It is shown at the end of that line. And there are two different kinds of associations, which I will tell you here. One is a composition, another is a aggregation. Just know those words. They are not required for our design pattern discussions, but association is three kinds: a weaker association, aggregation, and a composition. Now let's see a question. Design pattern is often referred to as GOF. It's actually a gang of 4 patterns. Those are the pioneer guys who put forth the first ever cataloged design patterns, but they are not the only ones. And here will come your answer. It was a pioneer book called Design Patterns, and if you guys get a copy, do read it. It's like a Dennis Ritchie of C, right? Very good book, but again quite scientific if you ask me. Feel free to read it. Documents some 23 patterns, and most of the object-oriented world is based on those patterns. That's where I said a pioneer book. So before we move into understanding factory pattern and a DO pattern, I'd like to pause and see if there are questions, and you will have to send the question. Okay, I will. I have a question here, and I'll take that question in a minute, or answer that question in a minute. Any other question? Okay, so I have a question from Divyang. If you could briefly explain DIP, dependency inversion principle, and ISP, interface segregation principle. So Divyang, I'm gonna explain it and see if that's gonna help. So dependency inversion principle talks about different level of abstraction. There will be higher level modules and a lower level modules, and we are saying that the modules at a same level of abstraction depend on that level of abstraction only and not below. For example, a copy program should not rely on a keyboard reader program. It should rely on a reader interface, right? So keyboard is a very specific specialized version of a reader which reads only from a keyboard, but copy program should not rely on that specialized version but rely on a abstract version called reader interface. So it is a level of granularity at which you see, right? That's the dependency inversion. A interface segregation will say that at the same level of abstraction, you should only know the things that you need to know, right? If I take a keyword, if you think of interface segregation, think of it from a point of view of a client and say what is needs to know, right? The client only needs to know on the basis of what is required for his operation to be done. For example, I'll take the same copy thing, right? For the copy example, you only need to know that there is a reader which can read. Do you really need to know the keyboard map or how it is reading and all that stuff? No, that's an interface segregation. But let's say there was a keyboard reader program. That keyboard reader program will need to have some information about the driver, right? The software drivers that will drive the keyboard to interpret the keystrokes. Now, in order to set those keystrokes, one would have to have a method called set character set, right? Character set is the way you interpret every keystroke and you convert into a ASCII or UTF code encoded characters. So anybody who's operating on keyboard in software world will have to tell what is the character set, and somebody will have to set the character set, right? So there may be a character set kind of interface exposed out, which the client will have to set. Now, does copy program need to know about the character set? No, because it just needs to know what is the data and it will write it. So in case of a copy program, the inversion of dependency inversion comes in by virtue of copy program not relying on keyboard but relying on the reader interface. That is also a interface segregation principle, because we are segregating an interface of a reader program differently than a program that can allow setting character code. I gave you a lot of descriptive explanation, and I wonder if I confused you further. So I'm going to unmute you and see what you have to say. Divyang?
Yes. Actually, ISP is clear to me, but DIP, about DIP, I'm still confused. What we are doing here? I mean, so just by creating interfaces, we are actually I'm still confused in PIP.
Sure. So let's talk about DIP. What does DIP? And I'm going to mute you for a minute, okay? So DIP is, let's start from scratch again, right? Let's say, let's take our example of a lockable door and a security guard, right? What does DIP will say? DIP will say that security guard can lock the door by use of a key, right? Does security guard need to know that the lock is a latch or a perhaps a bolt that can go on, or is it a proximity sensor lock or any kind of thing? All security guard need to know is there is a key, right, which you insert and turn, and the door will be locked. Now let's make it little complicated, and let's say it is not a key, but you have to tell security guard to make use of a pin. You know how those lock pickers will use that pin. Lock picker will go internal to that and somehow try tweaking the system such that it can unlock the door. Right? So lock picker's skill set is dependent on what kind of lock it is, but security guard does not need to know. Security guard just going to turn the key, and that's all. So what is the level of abstraction here? Level of abstraction for the security guard is security guard, a key, and a lock. Now lock picker on the other hand needs to know the lower level modules, and therefore he will most likely be unsuccessful when the lock changes. We don't want to build the lock picker, we want to build the security guard, is what dependency inversion principle says. If you start exposing your lock details outside world, your outside world will have to change every time you change the lock. Whereas the security guard just needs to have a new key, and that's about it. Why do we use dependency principle? Perhaps that will help. If you want to maintain a code for a long time, right, which Divyang, I guess you do, you would want to be exposing only relevant details and not expose any other things that the client is going to be using, will not be using, in fact. That way you will easily be able to swap out the underlying system. And by saying that I'll only expose you this much of detail at this level of abstraction, you're telling that I am free to change underlying implementation. You don't have to change. You're controlling the ripple effect. So I'm going to unmute you, Divyang, and see if that helped. And if it not, I would request we take that offline in the interest of time.
Yeah, sure. I will go through it and I have questions.
Sure. Thank you very much. So if there are no other questions, let's move on to seeing some code, which I wonder if you missed. I start missing things if I don't see code. So first we will be looking at factory pattern. It is a type of a creational pattern, allows us to create objects without use of keyword new. Always remember, all creational pattern we will try to avoid a new keyword in the client class. Let's say there is a cake as an abstract object and abstract class, and there are these 4 kind of cakes available. Black forest, pineapple, blueberry, and lychee. And then the class representation is going to be, or the client representation is going to be this. If we don't use factory pattern, what will end up happening is the client will have to create new objects all the time, right? And tomorrow, if you want to support one more object type, your client will have to change to add that new type, maybe a chocolate cake. But what is client really trying to do? Client is really trying to say that tell me about cake. It's saying cake dot about cake, right? Whatever cake is chosen by my user, tell me about that. But what we are doing here is we are also asking this client cake test to create that cake also. Now, in general, this is an general statement about the factory pattern, right? What ends up happening is client really asks a factory for the particular instance and uses that instance via some level of abstraction. In this case, we are showing interface. In last case, we said an abstract class. And client doesn't worry about how that instance is created. If I use the terminology on the screen, the client is going to talk to factory and say create product, and is going to use a product interface to use something called a concrete product. It is the factory who knows about concrete product and creates it. Let's put it at work for our own example. So instead of creating the cakes in our client class, we are going to say let's move that entire piece into factory. Factory knows about all kind of cakes can there be, and it will create those based on the input parameter cake name. And then we simplify our cake client or cake test client to say that get a cake factory and give it a choice, and you know the cake, and then you'd go about doing your business. What is the business here? Telling about the cake. Now tomorrow, let's say you want to add one more variety to the bakery, to your cake shop, right? Maybe a chocolate, right? And then what will happen is the client does not need to change. All things that need to change is the factory. And we will look at quickly the code. I'm gonna switch my screen to show you Eclipse, and we are going to look at the factory pattern. Here is your factory, right? And here you are going to support all the cakes that there are. And what I was saying here, and I'm going to start typing a code here. I hope my screen refreshes well in time. I'm going to say else if, right, I want to support new type of cake. I'm going to call it chocolate. Remember where, note where I'm making the change, right? Or I'm just saying choco, right? I am making a change in the factory class and not in my client class. Now it's going to give me a error here because I don't have that class created, a choco cake. But you get the idea, right? I don't need to change my client class. Client class is taking choice from the user and printing about that cake. And it is going to use a factory passing me a choice, and I'm saying when the choice is choco, create a choco cake. This is how, and imagine there were, now it is perhaps a CLI based client, right? Something which has a main method. Let's say there was a web based client. You don't have to change that as long as that client is taking the cake from the factory. There are variations to it because you are saying that cake should always be created from factory. You may end up creating all the constructors like this black forest, a default one, if it is in the same package. Okay. Thereby, nobody outside of this package will ever be able to say new package, new black forest. That's how you control the creation. But that's not important aspect in the factory. I'm just telling you the enhancement that one can do. Factory essentially says, Mr. Client, don't worry about how to create the object. Just tell me clues about which objects you need or what kind of object you need, and I'll create it for you. Another variation could be that after creating a cake object, you want to say bake it, right? So client does not have to bake it. This factory will say bake object, make it ready for consumption of the client and send it back. Okay, so that was the factory pattern. Let's move on. I'm gonna switch my screen again. And remember that this lab session is something that I'll be doing here, and you will have that code available to play with it offline. You will have it in LMS. Another important pattern is a data access object. It is essentially says that as an application, when you want to access some data, don't write code about database specific things. In fact, if I can abstract it out, don't write anything about the persistence, but just write that you need some data. So in your code, you will see in the diagram, your code is going to talk to DAO, which will talk to the actual persistence system. If any of us has used, let's say, a file system, they will know that in order to talk to file system, you have to open a file and put it into a wrapper like a reader and read it, or put it into a writer and write it and all that. We say don't do that, just use a DAO. So what ends up happening is client really uses a concrete DAO. There can be an abstraction of a DAO, and this concrete DAO uses the persistence system, may it be database, XML, or plain file. Let's look at the code. Let's say there is a course object, and course objects wants to do something. Let's say wants to store itself, and the method is not shown here, but assume that course object wants to store the method. Has a responsibility of storing itself. Remember, now again, a violation of single responsibility, because the course object is not only holding the data but also is responsible of persisting itself. We say don't do it, just create an interface called course DAO, which has this method called add course, update course, delete course, and then you create the special classes of it, saying that, oh, I want to store it into a database, and not only any other database but Oracle, right? And how do you use it? In the client code, or there can also be an XML persistence object, DAO object, or an Excel file persistence DAO object. And how does the client uses it? The client will say, I have a course, and instead of saying course.save or add, I'm going to say, let there be a DAO called, let's say, Oracle DAO, and add course, and that Oracle DAO will take care of persisting my course. The client may also say, I want to store it to XML file or an persistence file or something of that sort. Now, a point to note here is this is a simplistic example, right? So client chooses which DAO to do, which exact instance to use it. And if I may bring in the factory aspect to it, in a production grade system, what will happen is you will bring in the factory aspect. You will say, oh, I just need some sort of DAO, right? I'll use a factory pattern and say DAO factory dot get me the DAO, course DAO, and you will pass a parameter, maybe Oracle DB or XML or Excel, and the factory DAO will create these and give it to you. You'll always say DAO dot add object, add course. But in a simplistic form, DAO object really says that, or a data access object really says that, I will take care of where to persist. You just tell me what to persist. And with that, we will look at the DAO object as a example. Essentially, I'm going to show you only the same thing, right? You see DAO test, it is going to do all these things, and there are 3 things. Right now we are just showing it, but essentially these add course in here in an Excel file will start showing it to storing it to the Excel, and so on and so forth. And I'm going to show you now what I really meant by using a factory here. And as an assignment, if I may, when you get this code, I request you to convert this into a factory pattern. So you use the DAOs, but just like we were creating the cakes from factory, you create these DAOs from factories, so that you have a single example utilizing two design pattern, and then you will be able to appreciate that a single design can be a combination of multiple design patterns working together.